In this question, we are given the level of significance alpha, right, and the type of distribution, which is a two-tail hypothesis testing, and then we are provided with z statistical value. All right, so now what we want to do is, from the alpha level, you want to calculate the z critical and then compare the z critical with the z statistic and make a decision whether accept or reject. All right, now because we are given the two-tail hypothesis testing, it means that the alpha is going to be divided in two, because two tails, so those here, this level and this one here, they are the level of significance. So this is going to be just alpha over 2 here and alpha over 2 over here as well. And you notice they are symmetrical, right? So if alpha is 0.05, you're going to take 0.05 divided by 2, and this is going to be 0.0250. All right. So now, according to our hypothesis testing, we gonna divide the graph in two parts. So if you are falling, the z statistic is falling in here. Here we do not reject 80. Otherwise, you will be rejecting if you are outside of that boundary. So reject 80 here and reject over here as well. So as long as you are inside, you are good. If you are outside, you're going to be rejecting the null hypothesis, whatever it is. Now, the threshold over here, where the accept and reject start, all right, this is what we call z critical. And always, if you are dealing with a two-tail hypothesis testing, you're gonna have two z criticals and they are symmetrical according to 0. So one of them is gonna be positive, the other one is gonna be negative. Now, because we figured out already this left tail, the value is gonna be in here is 0.0250. So 250 basically we are looking for. We can use the z table and to figure out what is the z value corresponding of 0.0250. And the z table is just below. So here, obviously we are looking for a small tail, small proportion here, you see. All right, so we're gonna zoom in and we're gonna look for 250 as a value, and this is it. All right, there you go, big. All right, so you're gonna be this value over here. So once we extend and we read it on the sides, we can see 1.9, negative 1.9, and if I go all the way up, this is gonna be 6. So the value is minus 1.96, and you see it on the left side. So going back to our problem, so the value here, the critical value is going to be minus 1.96, and because it's symmetrical to the other side, it's going to be 1.96. So now we can finally compare or place the z statistic. So the z statistic, if we place it in, it's going to be minus 2.19. So definitely it's not going to be between minus 196 and 196. It's going to be placed, let me use black. So it's going to be placed somewhere in here, ZSTAT, which is negative 2.16. And you notice here is within the rejection zone, right? So we are rejecting, all right? So here we reject, and the reason is, let me see, so reject. All right, so they are giving you rejection if you are between what, two boundaries. and the correct one will be this. All right, reject if you are less than minus 196 and above 1.96. So that's the correct multiple choice. All right, so hope you understand it. Let's try to plug it in. So here gonna be 1.96, that's a negative, and this is 1.96, the positive bracket, and that's the correct answer. Okay, it was an additional question here. So we gotta choose the multiple choice which is matching our scenario. So the ZSTAT falls outside of the not reject zone. All right, so then the appropriate choice would be, since ZSTAT falls into the rejection zone, which is this. All right, we reject A0 and we're gonna check it, and I think that's all. All right, okay, that's the first question.